great to be back doing a presentation with Angel Mead, and I have a slightly different co-presenter this time. We have Steve Reed. We're both in the same group at Microsoft. We're both actually part of Azure Engineering, and we represent what's called the core services. And more specifically, specialized workloads within the core services. And what we do is we see how to best host the various types of systems that a lot of people don't necessarily think of would go to cloud, and mainframe certainly falls into that. So with that, I'm going to jump into sort of what we'd like to cover, and we'll do a brief intro of who we are and why you should even listen to us. Because, a lot of times people think, well, why should I be listening to Microsoft and about, my mainframes? Because that really wasn't their history. Well, that's not how Microsoft originally grew up, but there's a lot of people at Microsoft who do have mainframe background. And what we can do is show that, yes, we understand what a mainframe is and what it does, and then how you can utilize services on Azure in order to be able to move that workload into Azure. And we'll cover the different types of things that we can do. And that brings us up to the platforms that we cover. And the term mainframe is kind of an overloaded term. It can mean a lot of things to a lot of people. At Microsoft, when we say mainframe, we really mean IBM Z systems. That's typically what we mean, and that would be predominantly the ZOS systems. But there's also other systems out there. There's something called ZTPF for those in the reservations industry. They should be familiar with that term. But there's also non-IBM mainframes, particularly from Unisys. Unisys had a history of Burroughs and Sperry, and they both had their own mainframe platforms. And actually, they still sort of exist today because there's something called a Dorado and a Liberty versions of the Unisys mainframe offering, and we can also cover those. The next thing that we would go through is things like what are the goals and options that people have, because what we don't want to do is come in and say, hey, one size fits all, because it just doesn't. One of the things about mainframes is they were typically customized to a great degree to what a customer needed. So they would take it and they would get the right type of storage that they wanted. They'd adjust the compute. They would configure it in a way where the compute was being set up and things like LPARs, et cetera. And so there's a lot of different ways things can be put together. And depending on the maturity of the application, that also will decide whether or not you might want to more or less bring it over as is, perhaps to get out of the data center, perhaps to take advantage of cloud data that you can interoperate with, but not change the application. But you might also want to change the application. So there's different sort of approaches that you would take to do these things. And then we'll get into a little bit of the actual details of what it's like to do a transformation. And then finally, we'll just have a summary. And that will easily take up 35 to 40 minutes, whatever we have allocated for this presentation. And be happy to take any questions that come up too. So with that, I'll just do a brief intro. This is kind of like why even listen to me about mainframes? Well, I actually spent 17 years of my career prior to joining Microsoft, a little over 17 years, as a matter of fact, working with various mainframes. I actually worked with 370s. It's going back to the 70s. So it's, there, and I think the first one I did was actually a 360, but I only worked on that briefly. But anyway, I've also worked with several different, Unisys models. And we also consider enterprise Unix is something a lot of people sometimes think of as mainframes too. We think of that as more of being mid-range. But again, if that's something that you have, then perhaps that's some things that you would be interested in seeing what the possibilities are there too. And I've also been 26 years plus with Microsoft. So I came to Microsoft initially to try to get away from mainframes. But the fact that when I came, this is back in 1995, uh, I had that background, I sort of got pulled into any type of a project where we needed integration or with the mainframe or any kind of help in trying to move applications off, and sort of been doing that ever since. So, like I say, I work with the engineering team these days, but I've also, through the years, had a lot of work with commercial banking systems. And then I've also done other industries, including things such as retail, aerospace, automotive, logistics, et cetera. I'm originally from the Washington, D.C. area, but I currently live in North Florida because for family reasons, et cetera. But, I really concentrate on taking a look at these high volume transaction systems, because that's really what mainframes, at least from my experience, have been all about. Is you get into high volume transactions and you get into really highly available systems. Mainframes are noted for their reliability. Plus, you can have systems that are set up such that they can be resilient with the technologies, et cetera. And then we also do work with ISVs and SI partners, because Microsoft can't do everything, and no cloud provider does everything for a mainframe migration. So we partner very closely with software vendors and systems integrators to make that journey to a mainframe to be something that is both easy and predictable as you're going through. And then the final thing that we do is we look at what are the SLAs, what are the service levels we need in Azure to meet the requirements of mainframe customers. As I mentioned, most mainframe customers have a certain concept of what they think the reliability and availability of a system should be. So we work very closely with our core compute, core storage, core networking teams, core data teams, in order to have systems that can then meet that kind of a requirement. I know that Ron was mentioning, for instance, HPC today, maybe has what a mainframe had 8 years ago. Well, I actually kind of look at it the other way around. A lot of our customers these days, their mainframes are maybe 1/10 the size of what they're doing with HPC. Certainly in like the oil and gas industry, the mainframes that they have, while they're powerful machines, they have HPC environments that could be, again, 10 times that size. But I guess the point is that, the transactional systems you're working with do not live in isolation, that they have to be able to work with these other systems, which would include things like, the HPC systems. With that, I'm going to let Steve introduce himself.
Yeah, thanks, Larry. Hi, everyone. My name is Steve Reed. Not quite the storied and long career of in mainframes as Larry. I started working on mainframes in the mid 80s and in the financial services industry, and wrote basically banking software. And then I've been at Microsoft for 21 years, going on 22, in various roles. Before I joined Microsoft, and in between being a mainframe developer, I did a lot on Unix, on RISC 6000 and AIX systems. And when I came on board Microsoft, kind of like Larry, since I did have a sort of a knowledge of mainframes, I spent a lot of time with integration into mainframes, where it was back in the 2000s, where a lot of one of the big things to do was to connect different systems together in a service-oriented architecture. And one of those systems, typically for a large company, was a mainframe. So it did a lot with integration, various software products. You might remember something called BizTalk did a lot with that, because typically a lot of those workloads had to integrate mainframes. And yes, I've been working on that and working side by side with Larry, making sure that Azure is the best platform for running these legacy workloads.
Well, thanks, Steve. So I'm going to jump into the first thing that I, kind of like to address is why even consider Azure for a mainframe, or mainframe workloads. And there's some reasons. And the first off is geographic presence and amount of compute that you would need. Azure has grown quite a bit in the last number of years, and we have, we have data centers all over the world, and those data centers have really tons of compute that are in them. So if you compare the actual compute that's in our Azure data centers, it's many times what the current capacity is of mainframes. So we actually have the compute for it. It's really utilizing the compute that's the important thing that you have to look at, and getting the right systems available. The other thing that having all these regions means is that we have the network set up to have the high performance that you would need for these types of applications. And then the third thing that I would say is the fact that having this kind of capability for regions and networking means that we can have a sort of disaster recovery and backup regions available that perhaps weren't as affordable within your mainframe environment. One of the things that we do notice when we move to customers from mainframes over into Azure, we typically will have better RTO and RPOs. We'll have a shorter recovery point and a quicker time to be able to get the system back up and running, just because of that's just the nature of the cloud, and especially the Azure cloud. Then the last thing that I would put up there is that one of the things that we can do, especially with integration, and one of the things we recognize is not everything moves at once, meaning that especially with larger customers, you just don't bring a forklift in and take out the mainframe and then magically that runs in Azure. Usually there's a process for doing that. And that might include having this hybrid type integration, which Steve mentioned. And that hybrid integration, and certainly host information service is still around, as is BizTalk for that matter. And to have the latency that you need for these, having the edge sites that have good proximity into Azure allows us to minimize that latency. So even if you can't move your entire mainframe, you can be close to an edge site. And once you're within an edge site, you could then be on our backbone, whereas you get the power of the network. So these are some of the reasons why these big, powerful mainframe workloads might be appropriate to move into an Azure data center.
Hey, Larry?
Yes.
And just for some of your HPC colleagues, that same Microsoft infrastructure, I don't know how many hundreds of thousands of miles of fiber that Microsoft has previously laid across the ocean floor and owns, that same capabilities are equally applicable as they're looking at HPC workloads as well.
Well, that's a good point. And I'll even sort of pile on to that a little bit. We are not doing anything specific, with our use of Azure here that is not available to all of the different types of workloads. So you can get the kind of availability, et cetera, within Azure, even if you're not doing something that's coming from a mainframe. But the important thing for at least Steve and I want everyone to be aware of, we have experience of how to utilize those capabilities for systems that do come from the mainframe. Now, if you're going from HPC, then that's on-prem into the cloud, then we have the appropriate people like the other Steve to then be able to move that into the appropriate architectures within Azure. But the commonality is that it's all running within the same tenant, if you will, that a customer might have within Azure. So it's not like you have to build up one Azure for the HPC, another Azure for the mainframe. No, you can have it all within your Azure subscriptions within your tenant. It's just they're deployed in a manner that's appropriate for that application. So with that said, I'll go back into what I wanted to cover on this slide a little bit. And that's the fact that one of the really important things that we do is make sure that we meet the regulatory requirements and various other kinds of things that are needed. Now, I happen to be including what we do for government applications for in our Azure Gov, but most of these also apply to our commercial available products too. So we go through lots of different certifications that we need to have the type of both security and reliability that's expected from these systems. So this is part of the process for being able to then have new systems that come into Azure. So then the last thing, in sort of this intro piece that I'll go through is the fact that, just some of the attributes of what we consider important to be in a cloud systems and why Azure does it. We say the data centers have a certain availability SLA. That does not mean everything in the data center has the same SLA, but the data center itself has that SLA. You still need to have applications since if you're deploying an application and it has a problem, you just need to be able to fail over into another part. Well, that means the data center has to be there. So we have that capability within Azure. As a matter of fact, one of the ones I'll show a little bit later, we had a customer looked at, what is the availability for deploying in a Kubernetes cluster, an AKS in Azure, it's called, and compare that availability to what they were able to get with CICS and what's called a Kixplex running with the 2 physical mainframe boxes. And we got very favorable results. And the reason is because the underlying infrastructure is able to deliver that type of capability. But other things that we look at here is the availability of that commercial innovation in all these zones, that this is also done both in our commercial and our government. We try to keep parity within the two. Commercial is always going to be a little bit sooner than government, but we try to stay that within a 30-day freshness, through the time. We do have a very strong support for that hybrid cloud, meaning that, you don't have to do everything at once. You don't have to unplug and turn a light switch over a weekend. I've already discussed the redundant geographic capabilities, and then our network and our edge partners, and the fact that we do have, we do set up and look for, we assume attacks. Therefore, we're always looking for intrusion detection. And quite frankly, you can get information from Azure that tells you if you're vulnerable. I know if I deploy something in my subscription within Azure and it doesn't meet our internal requirements for that, I get what I call nasty grams from our security department that I should really fix these things. Now, sometimes I deploy it on purpose that way because I want to show, how not to set something up, and then, you can turn around and set it up. But, I'll still get, that notification from our security department that I had something that was vulnerable for that length of time. So with that, maybe I'll turn this over to Steve and he can talk a little bit more about the platforms we cover. If you're there, Steve. Well,
sorry, Zoom. I'm new to Zoom, so I got to find the mute button. But
okay.
About that. Yes, thank you, Larry. So yeah, let's talk about. You might have heard. I know when I was doing my intro that we used the term legacy. Larry and I do that.
Steve.
Yeah.
Steve, it's just Ron Gerber. One of the questions that Bill from Airline Reporting wanted to know was, in addition to these systems, how you might interact, be it the mainframe group or Azure in general, with Teradata Cloud or the Teradata on-site capabilities.
Well, I could touch that one. Not an uncommon thing to run into Teradata. I mean, it's one of the parallel databases that's been out there for a while. I remember back when NCR first came up with that way back when. But anyway, we do that either with the integrating with. I worked with a retailer that did what was, they called market basket analysis. They did that with Teradata, but they wanted to then take that information and then get more information about targeting customers through their rewards programs. So what we would do is we'd import data. There are standard utilities that you can import with Teradata and then move that into the Azure cloud. We happen to be doing it with Databricks, and then we would run Spark jobs within Databricks that then gave us this more targeted information, such that, the idea being that on their, their handheld device, if we saw them buying one thing, we could, recommend that they perhaps want to buy something else. Now that can go as far or not as far as we like. Some customers consider that intrusive, but if you opt into it, some customers really like that kind of thing. So interoperating with those parallel databases is a fairly common thing that we do, and we could do it either with their service or with it being on premise. And you can actually host Teradata in Azure too. So you can do all of the above if you're interested. We also do that with other flavors of parallel databases too. For instance, we do that with Netezza as well as Teradata. So hopefully that answers the question. And with that, I'll turn it back to Steve.
All right. Yeah, so what I was going to say was that we use the term legacy. You'll hear that, and it's actually kind of an umbrella term of sorts for the things that traditionally are non-x86, non-distributed, that aren't an easy lift and shift into a cloud platform like Azure. Larry mentioned the IBM Z. I would say, yeah, that's where we spend the bulk of our time, just because there's a lot of IBM mainframes out there, and there's a lot of folks that want to modernize those workloads, and Larry's going to touch on how the different paths of actually doing that. One that is probably not as popular, but is what we would still classify as a mainframe is Unisys, and Unisys has again another umbrella term, or a term that they have called Clear Path Forward. It's actually two different offerings. One is called MCP. It is for the Libra, the legacy Burroughs solutions. Now, the nice thing about what Unisys is doing is that they are actually creating the emulators for x86. So this is really good news, and it is a true lift and shift for their customers. So if you want to get off that legacy hardware from an old Burroughs system, they actually have a solution that is going to run in actually a Windows VM within Azure. And then they also have something called VM22, which is for the Dorado, which is for the legacy, like Larry mentioned, legacy Sperry, and that's going to be coming up later this year. So if you are on those two, hardware platforms, Unisys is providing a really good path forward, as the title denotes, for moving into Azure. And we're seeing a lot of interest with that. On the when you kind of go down towards, I know when I was doing banking, these were usually like at branch level, and a lot of store level retail. You find a lot of mid-range, right? Probably the dominant one I think that we see there is the power systems from IBM. And with power, you have the System I and the System P, and the System I for the OS 400, which used to be the AS 400s, and it's kind of a interesting system, very groundbreaking when it came out in a lot of ways. A lot of solutions, COT solutions were written for that. The good news there is that we actually have something called SkyTap within Azure, where we are hosting power systems within the Azure platform. So that really does provide you with a true lift and shift, because essentially what you do is you bring your LPARs from the power system and run them in, or port them over to Azure, and there's no recompile or anything like that you have to go through, and you have access to all of the cloud benefits, right, that a cloud platform like Azure would bring to you. Also, what we have is from within that, you'll see, and you might have remembered I did a lot with AIX, although the AIX I worked on was on the RISC platform, RS6000, but we have a lot of AIX systems out there. I've seen a lot, primarily most of what I've seen has been in retail, but we have, and we actually have some blogs and some architectures that we put together to show you how to go from AIX to Linux. A lot of those AIX systems were WebSphere Application Server, WAS, and so there's actually a pretty prescriptive way to migrate those workloads into a modern OS like Linux within Azure. So let's finish this up with talking about the Unix. I call it legacy Unix. And we actually have a graph on this, or an architecture slide that we'll touch on in just a little bit. But these are the legacy Unix like Spark, Solaris, and things like that, HPUX. And for a lot of this, there is a partner that we work with called Stromysys. And essentially what they do is they emulate this. They emulate it in a Linux VM, similar to what Unisys is doing with the VM2200. And believe it or not, I mean, a lot of these systems, were very fast. These workstations from the 90s and the 2000s, but the Intel platform is evolved to a point where the emulation really doesn't make that much of a difference. In fact, in some situations, the emulation's faster than the older hardware. And we're seeing a lot of interest from customers where they're out of support, right, for the hardware or something along those lines. So that kind of fleshes out the OSs that we deal with. I will mention that like when we're talking about Superdome and HPUX, HPUX is kind of interesting in that HPUX came out in a couple of different flavors, and if it was on the on some of the other x86 or the other platforms, I think it ran on RISC. The Itanium, we don't really have a solution for that right now. So that's just something to keep in mind. That's one of the ones where you're probably best looking at a rewrite or something along those lines, because there's no real path forward right now, at least for stuff or a lot of software that was written on the Itanium processor.
Yeah, I would say the solution for that is to migrate to Linux, whereas the PA RISC, which is the RISC platform, can be run through the Stromysys emulation.
Exactly. Yep. And if you go to the next slide.
And I'll jump back into this transformation. Actually, I'll let you do this one too, Steve.
Okay, sure. So when we start a conversation, and what will happen is somebody from the field, Larry and I are engineering, and somebody from the field will say, hey, I got a customer, they're interested in learning more about how they can modernize and migrate their legacy system into Azure. And so when we sit down and talk to them, what we find out is there's a number of things that are really driving them, right? And these are the challenges, right? One is just the increasing mainframe costs. Typically, for a given mainframe workload, what we can offer for that same workload, just not talking about all the other costs that go into the migration and everything, but for what you're paying IBM on a mainframe, typically we can do that for 10x less than that, right? From a infrastructure cost. And that's a very compelling ROI when you are incented by financially incented. The other thing, I think, Larry, you and Bob call it the silver tsunami. I've heard that term before. A lot of mainframe developers are retiring, and let's face it, they're not. There's not a lot of schools that are cranking out COBOL developers, but there are a lot of schools where developers are coming out and they know Java, C#, what I would say is a modern language, and so migrating to a modern language or a modern OS makes a lot of sense, because you're going to have a ready available skill set that can go and actually get you where you want to go. The other thing is just flexibility and choice. The cloud is all about options, right? It's about not being married to one particular decision you made 3 or 4 or 5 years ago. It's about being able to change that. It's about being able to take your data and actually find out where, predict the future and get closer to predicting what's going to happen tomorrow than, having reports that told you what happened yesterday or telling you what happened yesterday. So we see a lot of that. And one of the last one is agility, which I find to be really driven by more and more since almost 5 years that I've been, really focusing on this. Is DevOps has really become a main driver, where they like Azure DevOps. They like that whole approach, and they want to bring the mainframe into that world, right? So that they, I remember when I was for a brief stint, I was actually 4 or 5 years, I worked in a hospital system, and to make a rather simple change to some of these KICS programs would take like a month or a month and a half, 2 months, where in these other systems they could do it the same day. So the more and more you can get to having your software be more dynamic and agile is a huge thing that's driving folks towards modernizing. And you can go to the next slide. So real quick, and I'll turn it back over to Larry with this slide. What we have within Microsoft is, and this has been going on for a while, is we have an ecosystem. It's the Mainframe Transformation Program. And what this does is you can kind of think of it as some relationships. Primarily at the Microsoft level, we have people that are in the field that are talking to the customers. Like I said, Larry and I are in engineering, so we're very close to the people that are making Azure what it is, and so we can actually have meetings with them to talk about, hey, we need to try something different from a storage perspective or things like that. But none of that would actually be a complete offering or not holistic at all unless we had the system integrators and the ISVs that really offer these solutions, right? The solutions for taking those COBOL Kicks programs and providing a way to move those into x86. And so we do provide some tools and technology. Obviously, Visual Studio comes into play for a lot of this. Obviously, Azure and the everything that goes along with that Larry's talked a little bit about. But it's this entire ecosystem of us working with the partners and the tools that make this all up. It's really what is at the heart of the Mainframe Transformation Program.
Okay, and I'll pick it up now. Talk a little bit about transformation details. I think we're getting towards the end of the session here. I don't want to take away from HPC too much, but if we look at this, we have to look at what you're trying to do. I think I've mentioned that before. Do you really need something that has high availability with disaster recovery across regions? Do you really need high volume transaction systems? And if so, maybe you want platform as a service as opposed to VMs. Reason for that is it's easier to manage typically with platform as a service. And by the way, you might want your database to be platform as a service. And what we also find is people want to get to the cloud so they can unlock cloud capabilities. That includes access to analytics. It also includes bursting capabilities. And Steve already touched on DevOps. So the approaches, these are typical. This is what's been done for a long time, but we use the term rehost. Some people say replatform. That essentially means you want to keep things intact as much as possible, including the language. Refactor means I want to get rid of the language like COBOL, but I'm not ready to re-architect the entire system. And lastly, the re-architect would be that I really want to change to be more cloud native, meaning that I have a customer who wanted to take their COBOL batch program that did a lot of compute for financial services and changed that into something that ran with Spark and Databricks. Well, that's certainly possible, but you have to re-architect it and probably redo the data a bit to make that happen. So, we do say, let's pick the right approach that fits your business. And we have the, skills and can bring to the table the resources necessary to do any one of those types of pieces. And so this is just a sort of taking this and putting it in a slide that illustrates it, that we do have all these capabilities, and we can basically take almost any language that the mainframe has. Assembler is probably the hardest, but even there we have partner systems that can handle that. And ZTPF is the hardest operating system, at least that I work with, to migrate. But we are used to, we've seen this, we know it, and we've worked with customers on it in the past. So we know how to sort of approach this. And we know how to do it in a manner that is not going to disrupt business. In other words, we can do it in a predictable fashion, and we can do it in a staged approach, because most large customers aren't going to do everything over a weekend, like I mentioned before. So this just gives you an idea of some of the approaches and then the various tools that can be done to make that happen. I've talked to this a fair amount, so I'll skip that. I do want to go to the idea. People ask me all the time, how do I map compute that's on a mainframe versus compute that's on x86? And we actually did a study with it was HP at the time, with HP and Micro Focus. This was on premises, but it applies to running in VMs and Azure too. In fact, they're faster now running in Azure than they were when this was originally done in 2012. But mainframes are sometimes measured in MIPS, or millions of instructions per second. They're also measured in MSUs, which is millions of service units. I guess the point is that that tells you about the compute power of it. And so what we typically see is mainframes that might range anywhere from 300 MIPS to 100,000 MIPS. Well, how do you then size that for the compute that you need in Azure? We also find that workloads vary a bit. A lot of mainframes have batch versus online. And even if you convert that over into being more event-oriented in Azure, you're still going to have some longer running transaction processes, which are in essence like running a batch. So what we found is that you could get about 170 MIPS for every vCPU or core of x86 for batch, and 288 MIPS for every online CICS comparisons. And this is actually published where you can go out and read about this, etc. And I guess the point here is that this has actually gotten better over time. I like to be a little bit more conservative about this. I like to go more for the 150 MIPS per vCPU. But if I had 1,000 MIPS, that means I don't need that many vCPUs, right, in order to get those 1,000 MIPS. I could easily do that with 10 vCPUs, for instance, because that's that's only 100 MIPS per CPU, and that's easily doable within most VMs or in most services like Azure Kubernetes service, which could be doing your compute for you. So this just gives you an idea of the fact that you can indeed get the power that you need, in an Azure compute, using our standard VMs and services. So I do want to touch on this one briefly. I'm not going to, go through it in tremendous detail, but this looks at two different approaches. One of them is more refactoring the application. That happens to be on the left side of the stack here. This is where we took something and changed the code from COBOL to Java. Then we deployed it in app servers, and then we ran that. We containerized it and then ran it in AKS clusters. And we actually do see that running. That's Azure Kubernetes Services for the acronym. And what we're able to do there is both load balance and provide a highly available, clustered system in order to take that advantage of that. And also that can be regionally available. So you can not only have the power that you need, but you can have high availability and also recovery within regions. Now you can do something similar with VMs. This is more of what would be called more the lift and shift or the rehost, where you're still running the COBOL as COBOL. You need to have some type of a system that we get from an ISV partner that then works like an app server, if you will, that then would be running the equivalent of the CICS or the IMS transaction manager kind of functionality. And that can also be run with multiple VMs. So you can actually put that into a load balanced cluster. That way you can get high availability with that too, rather than having a single point of failure. And you can take advantage of other features. For instance, I've got Redis Cache or RDMA, which our HPC folks would, I'm sure, be familiar with. That would be you could use for memory sharing. Now you have to have a VM type that supports RDMA, but if you have that, then that's also available for the applications to share memory as it goes through. And then you can use one of our PaaS type databases, or you could be using, you could bring your Oracle over if you wanted to, and you could use that running in Azure too. And then finally, underneath the covers, we've got the storage, and we can have storage that's automatically redundant, which is more the blob storage, or we could have our managed disks, and that you could use things such as the database's ability to replicate for high availability to keep them in sync across multiple regions. So even if you're using the different ways of deploying the compute, the actual storage would probably be the same. And then the other things I have down here is things like having the actual storage accounts, using Azure Data Factory for integration, and then having things like Azure Site Recovery, which is what we provide this very convenient and relatively inexpensive way to allow for the ability to run in separate regions, that you could fail over to a region in case the whole region went down. So Steve, you want to cover this one quickly?
Sure,
Hey,
sure.
Steve, we've already gone about 40 or so minutes. So just to be fair, we can have some questions. If you could start summarizing so we can make sure we get to the HPC content as well.
Yeah, I thought we'd be doing that. You want to do this real quick, Steve, and I'll go to the summary?
Yeah. So this is just an example of an emulation workload. This was created. We actually have these reference architectures out online. This shows you the Karen product by Astromesis, and you can see how we have multiple Solaris VMs within Red Hat Linux. If I would encourage you, if you're interested, we've documented this there's a white paper on this as well as a reference architecture.
And we have a link to the architecture site is at the end of the presentation, which we're going to make available. And this is just some customer examples. I don't really have time to go through them, but this one is actually this one I can use the name because it's a public case study with the U.S. Air Force. This one is another public case study with Geico Insurance. This one is with a credit card company that, or they're a processor for credit card systems. Now, we don't have permission to use their name, but we can talk about the approaches. And this was a fairly large one. It's over 50,000 MIPS. And this is an even larger one, over 200,000 MIPS, which is one that's being done with capital markets systems. So there's some pretty big systems that we can look and move into Azure. And again, these are things we can provide more detail as we move along. And this will get very quickly to the summary. We do have a lot of company resource and experience, and we've got the technologies in place to get these things done. And we also integrate in with our partners, and we work very closely with all of these. And with that, this is just our reference slide. So I tried to finish up. Hopefully, that was of use to you, and I'll turn it back over to Ron.